Hello, this video has been developed to inform you of the goals and objectives of the WTEC assessment team on micro-manufacturing. We are conducting an international assessment of research and development in micro-manufacturing. This study is co-sponsored by the U.S. National Science Foundation, Department of Energy, and Office of Naval Research. WTEC is the leading organization in the U.S. conducting international technology assessments via expert reviews, and has conducted about 55 such studies since 1989. Reports from previous WTEC studies can be found online at the website shown here. The objectives of this project are to assess the emerging global trend toward the miniaturization of manufacturing systems, equipment, and processes for the manufacture of micro and mesoscale components and products. This is the so-called microfactory manufacturing paradigm. The WTEC team is also charged with identifying scientific, technological, commercialization, and other barriers that must be overcome to successfully implement the microfactory paradigm. We will also assess the potential economic and environmental impacts of these technologies and identify the trends and critical R&D needs and future directions for micromanufacturing. The scope of this study will emphasize parts and features with three-dimensional surfaces and high relative accuracies in a wide range of engineering materials by non-lithography-based processes. This study will not focus on MEMS, as a similar study by WTEC on this topic has been conducted in the past. However, it is understood that MEMS may be incorporated into this study, as it is certainly part of micromanufacturing. There are three key principles that should be explained about the WTEC study on micromanufacturing. The first is that the study will be open to dissemination and will be located on the website shown here. The second is that the study will be mutually beneficial to all participants. Participants from Europe, Asia, and the U.S. will have input to the report that is generated by the WTEC team. All participants will also have access to all published information by the WTEC team, enabling exchange of information on an international basis. Finally, all hosts will have the opportunity to review draft reports generated by the WTEC team prior to public dissemination. The host institutions will receive two opportunities to review all reports prior to public dissemination. Any material deemed proprietary by the host will be removed before the release of the final public report. This is also an opportunity to ensure that the information included in the report is accurate and correct. Furthermore, any additional information that the host institution would like inserted into the report can be added at this time. The project team consists of 8 expert panel members and 3 other members from the team's sponsoring organizations. The expert panel members include Professor Beth Allen from the University of Minnesota, Professor David Burrell from the University of Texas at Austin, Professor Richard DeVore from the University of Illinois at Champaign-Urbana, Professor Cornell Amon from Northwestern University, Professor Tom Hodgson from North Carolina State University, Professor Thomas Kerfus from the Georgia Institute of Technology, Professor Mark Madhu from the University of California at Irvine, and Professor Kamlakar Rajakar from the University of Nebraska at Lincoln. Each of these panel experts have been chosen for their expertise as it applies to micromanufacturing. Other members of the team include Dr. Jen Chow from the National Science Foundation, Dr. Khurshid Cooper of the Office of Naval Research, and Dr. Phyllis Yoshida of the Department of Energy. Micromanufacturing is of interest because the emerging miniaturization technologies are viewed as key technologies of the future. Also, as products become smaller, smaller components are required with complex shapes in a variety of materials with increasingly tighter tolerances. To address these needs, manufacturing systems, equipment, and processes are being developed. In many cases, these items are being miniaturized themselves. There is clear evidence throughout the international community of the growing interest in the microfactory paradigm. There are a variety of application areas for micromanufacturing, including the medical area, electronics, communications, energy and power, and optics. This list is just a few of the application areas for micromanufacturing. The development of micromanufacturing capability will be critical to bringing these concepts to reality and eventually to the consumer market. Three major research areas in micromanufacturing have been identified. The first is microscale process fundamentals and modeling. For example, grain size can have a significant effect on the final quality of a part produced by micromanufacturing. For example, the micropins shown in this figure were generated with the same process and the same materials, with the exception of the grain size of the material. The material with a larger grain size was used for the lower pin. The grain size is approximately the same size as the diameter of the pin, causing it to warp as shown in the figure. The pin at the top of the figure was produced with the same process and same material, with the exception of a smaller grain size. Clearly, the material grain size has had a significant effect on the component's quality, as is demonstrated in this example. The second key research area is microscale process innovations and device development. In many cases, the production of microscaled components has been achieved successfully by miniaturized process equipment, by the use of advanced sensors and actuators, as well as new microspindles and microslides and controllers. The third area of important research is the integration of microscale devices into autonomous systems. This area of research addresses the concept of integrating the variety of microsystems developed for micromanufacturing into an overall global system. This study will focus on microscale manufacturing processes and systems for the manufacture of microscale components and assemblies in a range from about 100 microns to 10 millimeters. It will also focus on processes and applications that contain three-dimensional free-form surfaces such as the figure shown below. The study focuses on processes that employ a wide range of engineering materials, including but not limited to metals, composites, polymers, and ceramics. The study addresses processes with relative accuracies in the range of 10 to the minus 3 to 10 to the minus 5. Relative accuracy is defined as the ratio of tolerance to dimension. For example, a 1 millimeter dimension with a tolerance of 1 micron would have a relative accuracy of 10 to the minus 3. The study will target the microfactory manufacturing paradigm. In particular, it will focus on the development of miniaturized processes for the manufacture of microscale components and assemblies. In August of 2004, a U.S. kickoff workshop was held for this study. Leading industry and university experts in the micromanufacturing area gave presentations in Washington, D.C. during this workshop. A copy of the workshop report, as well as all presentations given at the workshop, will be made available to all groups hosting the WTEC team on micromanufacturing. This report provides a baseline for U.S. needs, interests, and capabilities in the micromanufacturing area. Key subject areas that were discussed at the U.S. kickoff workshop include design, materials, processes, metrology, sensors and control, applications, business, education, and the environment. The chapters of the final report from the WTEC team on micromanufacturing will focus around these 6 critical topics. During the U.S. kickoff workshop, a number of recurring themes were identified. These include a difficulty in achieving feature size and accuracy with the current macroscale manufacturing equipment. The need for multifunctional machines that combine several processes, such as machining and measurement, was identified. Problems associated with part handling, fixturing, and repositioning, driven by the part size and its tolerance requirements, was also identified as a recurring theme. Once parts are produced, they must be assembled into functioning devices. Therefore, assembly was identified as a critical element in the workshop. Metrology was also identified in terms of quality control and process improvement. The need for both measurement of components after being manufactured as well as in situ measurements was identified. Another recurring theme that was identified was equipment cost reductions that can be realized by reducing the size of micromanufacturing systems to produce the microcomponents. Material issues were also identified in the workshop, in particular microstructural effects, consistencies of properties in materials used at the microscale, and the integration of multiple materials into a single component. Many of these issues identified are not well understood from a fundamental perspective. Thus, there is a need to better understand the influence of scaling on the various fundamental issues of process and product performance. Significant discussion was held on intellectual property, in particular the relationship between industry, academia, and government entities regarding the ownership and utilization of new concepts that have been developed in joint research projects. Finally, it was clear from the discussions that new and innovative concepts will lead the micromanufacturing revolution. Therefore, the need for out-of-the-box thinking is critical. With these issues in mind, a schedule was developed for the production of the WTEC survey report on micromanufacturing. As previously stated, a U.S. survey workshop was held in August of 2004. In December of 2004, the WTEC evaluation team visited sites in Japan, Korea, and Taiwan. In February of 2005, the team hopes to visit a variety of sites in Europe to complete its survey work. On April 21st through the 22nd, a workshop will be held in Washington, D.C. to report on the preliminary findings of the micromanufacturing team. All hosts are invited to attend and participate in this workshop. Finally, in September of 2005, a final report will be published and presented to all hosts. This concludes the presentation of the WTEC study of micromanufacturing. If you have any questions at all, please feel free to contact us. Our primary contact is Professor Amon at Northwestern University, who is the expert panel chair. Thank you.